Hello students, this video is about the topic conservative and non-conservative forces. So let's start with the conservative forces first. To define conservative forces, we can say that a force is conservative if the work done by that force in displacing a particle from point A to point B or from one point to another is independent of the path followed by that particle, and it only depends on the initial and the final position. For example, if you have 2 points, first is capital A, second is capital B here, and we are trying to move a particle from A to B along two different paths. So first path is this is the path number 1. Particle is going from A to B, and this is path number 2. From path number 2, particle is also going from A to B, but the path traveled by the particle is different. So if the work done by the force in displacing the particle from point A to point B from both the path 1 or path 2 is same, it is independent of what path we have choose for the traveling of particle from point A to B, it only depends on the initial and final position, then we call that force as a conservative force. So we can define conservative force as a force if the work done by the force in displacing a particle from one point to another is independent of the path that we have taken, is independent of the path, but depends on the initial and final position. Then such force is called conservative force. So for a conservative force, if there is a conservative force acting on the particle and particle is moving from point A to point B along path 1 or path 2, then in that case work done while moving a particle from A to B along path 1 is equal to work done moving a particle from A to B along path 2. In both cases the work done will remain same. If this condition is valid, then the force because of which this work is happening or that is acting on that particle, that force is called a conservative force. Now if the particle moves in a round trip, means if it goes from A to B and then come back to A, means if we have 2 points A and B, particle is going from path 1 from A to B and then it is coming back to point A again from some other path 2. Then in this case, if particle is making a round trip, then in the case of conservative forces, the work done in A to B, work done in moving particle from A to B along path 1 is equal to the negative of the work done on the particle moving from B to A along path 2, because these forces were equal if we go from A to B from path 1 or A to B from path 2, but in this case in the round trip we are coming from B to A. So to equate to work done we have to put a negative sign. That means work done while moving from A to B along path 1 is equal to negative of work done while moving from B to A along path 2 if the forces acting on the particle are conservative. So now we can write it as WAB along path 1 plus WBA along path 2 is equal to 0, or this means that work done from moving A to B along 1 and B to A along 2, that net work done is 0, means work done for the closed path is equal to 0. Hence, we conclude that if conservative forces are acting, then the work done by the force in moving a particle around any closed path is 0. This is the condition for conservative forces. A force is conservative if the work done by the force in moving a particle around any closed path is 0. So, this is also how we can define a conservative force. Now the non-conservative forces are just opposite to each other, means they depends on the path on which the particle is moving or the path chosen by the particle to go from position 1 to position 2. Hence we can define non-conservative forces as if the amount of work done in moving an object against a force from one point to another depends on the path along which that body moves, then such a force is called non-conservative forces. Okay, so the definition for non-conservative forces is if the amount of work done in moving an object against a force from one point to another depends on the path along which the body moves, then such force is called non-conservative force. So non-conservative forces are opposite to the conservative ones. If we see their examples, so for conservative, the very common example is gravitational force. It is a conservative force. And for non-conservative, the very common example we have is force of friction. Also, force of viscosity is an example of non-conservative forces. Now, after this, there is a relation between potential energy and conservative forces that we are going to derive now. So, if there exists a system of particles, we have a system of particles such that conservative forces are acting there. We have a system of particle in which conservative forces are acting, then the potential energy associated with that configuration of the system, there must be some potential energy is associated with the configuration of that system, and there are conservative forces acting in that system. So we can say that when the conservative force does work on a particle within the system, there is a change in potential energy. Okay, so if we have a force Fx, we are considering it Fx just for the sake of calculation and keeping the dimension simple. So if we have a conservative force Fx which does some work W on a particle within the system, This force does work W on a particle within the system, and because of that there is some change in potential energy. This is delta U. So this change in potential energy of the system is equal to the negative of the work done by the conservative forces. This is the relation. This potential energy is equal to the negative of the work done by the conservative forces, but we know that this work done is equal to integral of fx dx while the particle is moving from initial to final position. So the displacement is from xi to xf. We can write w is equal to integral xi to xf fx dx, and we are going to substitute this value in potential energy. So delta u is equal to minus integral xi to xf fx dx. Now if we differentiate above equation, we get du over dx is a function of x, because change that we have considered is a function of x, force is a function of x. That's why du over dx is equal to minus fx, or fx, that conservative force, is equal to minus du over dx. Now this means that potential energy can be defined as a function whose negative gradient, since the differentiation is with respect to x, so we call it as gradient, the negative gradient gives the force. So potential energy can be defined as a function u whose negative gradient give us the value of force, or we can also say that conservative force is a force which is equal to the negative gradient of potential energy u. So either we can say that conservative force is the negative gradient of potential energy u, or we can say that potential energy is a function whose negative gradient is that conservative force present in that system. So this is the relation between potential energy and conservative forces. That's all for the video. For further videos, stay tuned and keep studying. Thank you.